My name is Eric Henenfent, and I'm a security engineer at Trail of Bits. This video will showcase some of the features of Manticore, our open-source symbolic execution tool. Manticore was designed from the ground up to have a flexible state management lifecycle, enabling it to simultaneously support architectures as different as x86 and EVM. Manticore can be used to solve traditional CTF challenges, like this one presented at DEF CON CTF in 2016. As you can see, the code of this challenge is heavily obfuscated. It's effectively impossible to follow by hand, so clearly it will require automated tooling to solve it. Let's use Manticore to explore all the possible states this program can reach. After a few minutes, we can verify the solution of this challenge. We can see that one of these states has found the flag, which is math is hard. Additionally, Manticore can be scripted to inspect and analyze certain program states. Let's review a simple example, a script used to count the number of instructions. We also present the following example in our paper, which shows Manticore's rich API. In this script, we define a function to run every time Manticore reaches a certain instruction. This hook can perform a variety of operations over our state. First, it can discard the state to end the exploration if certain conditions are met. If we decide to explore the state, Manticore can be used to add new constraints, as shown in the example. Now, let's look at Manticore's capabilities on Ethereum smart contracts. In this vulnerable token contract, users can buy tokens by calling the fund method and destroy tokens by calling the burn method. A user can take control of the contract by calling the take ownership method, which requires the caller to own more tokens than the current owner. Since the fund method automatically grants tokens to the current owner if the number of purchased tokens is less than the current owner's balance, it should only be possible to take over the contract by buying more tokens than the current owner has in a single purchase. Manticore, by default, will create an attacker account with a balance of 1,000, which won't be enough to surpass the owner's starting balance of 1 million tokens. It should be impossible to take over the contract. However, there's a bug in the burn function. If an attacker attempts to burn more tokens than they currently own, they can overflow their balance and gain an absurd number of tokens. Let's run Manticore on this contract and see if it can find the bug. We can see that Manticore's overflow detector first warns of an overflow after the second transaction. The only way for this to happen should be calling fund immediately followed by burn. If we look through the resulting test cases, we can see that just one resulted in a successful call to take ownership. Let's look inside. Here's a record of the transactions that allowed the attacker to take control of the contract. After the owner creates the contract, the attacker buys a symbolic number of tokens, concretized to 490. They then call the burn function with a massive symbolic argument, which overflows their balance and grants them a massive number of tokens. After that, they're able to call take ownership and have it stop successfully instead of throwing a revert. As we've just seen, Manticore was able to symbolically evaluate sequences of transactions, including one that revealed a bug in the contract. Manticore includes a few detectors for common problems with smart contracts, things like self-destructing contracts, integer overflows, and use of uninitialized storage. We're proud that Manticore, as an analysis framework, is flexible enough to handle execution of both smart contracts for the blockchain and Linux binaries for native platforms.